हॅलो मॅडम, मी याच्यावर नेट कनेक्ट केलं. थांबा, याच्यावर कॉल नका करू. चिंचे सर करतील तुम्हाला. राठोड मॅडमला फोन करा. सर नाही, तुम्हीच बोला. थांबा म्हणून सुरू झालं म्हणून ऑनलाईन. डॉक्टर पंकज खिराडे. Hello, dear participants. I, Dr. Pankaj Khirade, welcome you all for this online session for the presentation and demonstration of physics experiments. Today we are having Dr. Zakir sir from VME College as a referee for this online competition, as well as Dr. Archana Bodade madam from Department of Physics, Sri Shivaji Science College, Amravati. Okay, now we will start the presentation session. For that, first I will invite Aditi Pawar. Aditi Pawar, are you there?
Sir, how we share our screen?
Aditi.
Abhinav,
Hello.
are you there?
Yes. Am I audible?
Yes, you are audible.
Okay, sir. Should I present my screen?
Yes, you are co-host now. You can present your work.
Okay, sir. Thank you, sir. Hello. Is my slide visible?
Yes.
Okay.
Please continue.
Okay. Greetings to everyone. I am Abhinav Prashant Gutmare, a BSc second year student from Sri Shivaji Education Society, Amravati Science College, Nagpur. Today I will be demonstrating an experiment. The aim of that experiment is to study the VI characteristics of LED and to determine its cut-in voltage. This is the outline of that experiment, what we are going to discuss further. First, let us discuss what actually is LED. A light-emitting diode, which is abbreviated as LED, is a semiconductor light source that emits light when current flows through it. A semiconductor diode, a semiconductor device with two terminals typically allowing the flow of current in one direction, is called diode. The basic difference between the LED and the diode is that when the current flows through the LED, it emits light, while the diode converts AC current into DC, and this process of conversion from AC to DC is known as rectification. The operating principle of light-emitting diode is based on electroluminescence phenomena. Now the question appears, what actually is electroluminescence phenomena? So, electroluminescence is the property of material to convert electrical energy into light energy, and later it radiates the light energy. the recombination of electrons and positive holes in a semiconductor produces light. A LED is a PN junction diode which emits light when activated. Based on semiconductor material used and the amount of doping, a LED will emit a colored light at a particular wavelength when forward biased. The light is not particularly bright, but in most of the LEDs, it is monochromatic, occurring at a single wavelength. Now the question appears, what is doping? So, doping is nothing but the introduction of impurities into an intrinsic semiconductor for the purpose of changing its electrical and structural properties. Let us discuss the objectives of this experiment. This experiment is performed to determine the voltage required by different colors of LED. In this, we will determine the cut-in voltage, threshold voltage, which is also known as knee voltage, and the voltage to current characteristics, which is VI characteristics of the LED. So, the apparatus required for performing this experiment are as follows. We require 3 LEDs of different colors. Here, we are using a red, green, and a blue LED. We are not restricted to choose only these 3 colors. We can choose any colored LED for performing this experiment. Again, we require a variable DC power supply, a voltmeter, a milliammeter, a resistor, and some patch cords. Patch cords are nothing but the connecting wires. The formula for finding forward resistance is R of F equals to del of V of F upon del of I of F. Here, we are not considering the reverse bias condition because if the diode is connected in reverse bias, it will oppose the flow of current in the circuit. And due to this, the LED will not emit light. Hence, the LED is always connected in forward bias. Now the representation of LED. The LED is represented in such a way. Here the anode is the positive terminal of LED, while the cathode is the negative terminal. The 2 small arrows originating denotes the emission of light. Now let us discuss the energy band diagram. When the voltage is supplied to the circuit, the electrons present in valence band get conducted to the conduction band, leaving positive holes in valence band. Now, as we know, an atom can remain in excited state only for about 10 to the power minus 8 seconds. After this time period, the electrons will return to its ground state and it will release energy in the form of photons, which is the light energy, where the forbidden gap is nothing but the energy difference between the top of valence band and the bottom of conduction band. The highest energy level that an electron can occupy at absolute zero temperature is known as Fermi level. This is the circuit diagram. Here the voltmeter is connected in parallel and the milliammeter is connected in series connection. Here R of S is nothing but the resistor, and this is the LED which is connected in series connection. Now let us discuss the procedure for performing this experiment. First of all, we will connect the voltmeter, resistor, ammeter, and LED as directed in the circuit diagram earlier. To find the variation in current, we will slowly increase the voltage starting with 0 volts in small steps of 0.1 volts up to 3 volts, and will note the value of current at every moment. Then, according to the readings obtained, we will plot the graph. Initially, the graph increases non-linearly, but after some voltage, it starts increasing linearly. We will repeat the same procedure for remaining 2 LEDs. On performing this experiment, we get such type of observations. Let us discuss the observations obtained for red LED. Here, till 1.6 volts, we don't see any deflection in current. Now, as we increase the voltage to 1.7 volts, we see a very slight increase in current, and due to this, the LED starts glowing lightly. The voltage at this point is known as threshold voltage or knee voltage. Again, on increasing the voltage, we see a significant increase in the current, and it goes on increasing till 2.1 volts. Upon plotting a graph for red LED having forward voltage on x-axis and forward current on y-axis, according to the readings obtained, we get such type of curve. Here, the resistance of the resistor, which is connected to the circuit, is 1 kilo ohms, as mentioned earlier. The threshold voltage obtained was 1.7 volts. To find its cut-in voltage, simply we have to draw a tangent from the point from where the current starts increasing rapidly. The cut-in voltage for the red LED is found to be 1.72 volts. To find the forward resistance, we will have to take the slope of any 2 points on the graph. on taking reciprocal of the slope, we will get the value of forward resistance. Note that the values of voltage is in volts, which is SI unit, and the value of current is in milliampere, which is CGS unit. So we have to convert the value of current into SI unit by multiplying it with 10 to the power minus 3. Here the forward resistance obtained was 32 ohms. These are the observations which we obtained for green LED. Upon plotting a graph for green LED, we get such type of curve, and these are the values which we obtained after calculation. Again, the same, these are observations which we obtained for blue LED. Upon plotting the graph for blue LED, we get such type of curve. These are some graphs which are plotted while performing this experiment. Now, let us discuss voltage to current characteristics, which is abbreviated as VI characteristics. Here, the red LED requires the lowest voltage, yellow and green LEDs require a slight higher voltage, and blue and white LEDs require the highest voltage. LEDs emitting infrared color consumes the least amount of power, while the white color consumes the most. The voltage for the remaining colors can be seen in this graph. Now, let us discuss some advantages of using LED. LEDs is highly energy efficient. It is cost effective. The emitted light is monochromatic. No warm-up period is needed. It means that the LED will reach its full brightness as soon as turned on. The light intensity of LED can be controlled easily by varying the voltage in the circuit. Now, the applications of LED. LEDs are used in digital watches, calculators, multimeters, remote control systems, burglar alarm systems, traffic signals, camera, flashlights, etc. So, the final result obtained after performing this experiment are as follows. The cut-in voltage for red LED is found to be 1.72 volts. The cut-in voltage for green LED is found to be 2.32 volts. And the cut-in voltage for the blue LED is found to be 2.5 volts. Again, the forward resistance obtained for the red LED is 32 ohms. The forward resistance for the green LED is 100 ohms. And the forward resistance for the blue LED is 41.7 ohms. Here are some precautions which are to be considered while performing this experiment. First, make sure that the connections are tight. Second, take care to apply suitable forward voltages across the LED to avoid any damage to the LED. Now, one more precaution should be considered. Avoid connecting LEDs in parallel. We should not connect several LEDs of different voltages in parallel with just one resistor shared between them. It is because if the LED requires slightly different voltages, only the lowest voltage LED will light, and again, it may be destroyed by the larger current flowing through it. Although identical LEDs can be successfully connected in parallel with just one resistor, as the current used is same as connecting the LEDs individually. Note that for connecting LEDs of different voltages in parallel, each one should have its own resistor. So this was all about the experiment. Thank you very much.
Abhinav,
Yes, sir.
can you show your face?
Yes, sir.
Very good explanation.
Thank you, sir.
Abhinav, have you performed these experiments in your laboratory?
Yes, sir. I have performed it.
Okay. So, please tell what is the difference between luminescence and general light?
So can you repeat the question again, please? What is the difference between?
Luminescence and general light.
Sorry, I'm not getting the word. And general light, and what was that word? So,
Incandescent.
oh. Mm.
Okay.
Sorry, sir.
What is the role of temperature in luminescence?
So as the temperature increases, means if we compare it with semiconductor, so when the temperature increases, the semiconductor acts as a conductor, means at a higher temperatures. So illumination can also increase with temperature. Or,
Vinod,
yes.
how can you correlate the cut-in voltage for a particular LED with the light or its wavelength from that LED?
Okay. The cut-in voltage is that the means maximum change in current. Means it is the point where the current starts increasing rapidly, and
Okay, cut-in voltage, but how it is correlate? How it can be correlate with the wavelength emitted by that particular LED?
I think so. We can determine. We can just consider that the least cut as the least cut-in voltage, it will have the higher wavelength.
Okay. What is the formula?
For what, sir?
What is the formula which gives this correlation? Wavelength and the starting voltage or cutting voltage. Can you determine Planck's constant with the same results?
Planck's constant means the energy equals to Planck's constant into frequency, which can be also determined as energy equals to the Planck's constant into speed of light upon wavelength.
Okay, then my question is, can you determine the value of Planck's constant using the same result that you have obtained in the characteristic of LED?
We have to determine Planck's constant, right? Okay. So upon performing this experiment, we will get the value of wavelength required by the and
Okay.
Okay. Thank you very much.
Okay. Next participant is Achal Mishra, BSc second year. Are you ready? Achal Mishra.
Sir, 2 minutes.
Okay. I have make you co-host so you can share your presentation. How many time you require?
So only 2 minutes I required.
Okay. Achal Kamble, are you ready?
Yes, sir.
वैष्णवी वानखेडे आहे का?
Practical of physics.
Hello, sir.
वैष्णवी वानखेडे. अचल काळेचं सुरू करू. अचल कांबळे.
Sir, I am
sir.
ready. Excuse me, sir.
Yes, who is this?
Achal Mishra, I am ready.
Yes. Okay, you can share your PPT. So त्याचा व्हॉल्यूम ना कमी करून टाका सर, साइडचं बटन दाबून आणि म्यूट करून ठेवा, मग ते इको येणार नाही. केलं तिला ऑलरेडी. Hello, please share your PPT.
Yes, sir. Yes, sir. 2 minutes. Sir, I am visible. Excuse me, sir.
Have you shared your PPT?
Yes.
Your screen still is not visible. Share once again. Are you using mobile phone or a laptop?
Mobile phone.
Click on share screen option, green color. And then choose that open PowerPoint presentation window. Okay, do you have any idea to share the PPT? Or you can take
On
help
mobile.
of
So
you
please
take
give
help
help.
and give presentation after 10 to 15 minutes. Okay.
Yes.
Achal Kamre,
Yes, sir.
share your PPT. I have make you co-host. Yeah, second.
Hello, sir.
No, your PPT is not visible.
Okay, sir. So, oh, sir. Screen share नहीं होते हैं.
दिसलं का तुला? आचल
Hello, sir.
Share
सर
screen option दिसते.
हाँ
Green
सर पण
color मध्ये.
व्हिडिओ शेअर करायचा आहे.
Okay, ठीक. एक स्लाइड दिसत आहे तुझी. काय आहे स्क्रीनवर? युनिवर्सची स्लाइड दिसत आहे. अचल कांबळे,
यस सर.
पीपीटी होत नाहीये का शेअर तुझं?
नाही सर.
ठीक आहे. नेक्स्ट वैष्णवी महामुने. ऋतुजा आहे का? दायजे ऋतुजा.
Yes, sir.
बी रेडी.
Okay, sir.
Okay, you can share your PPT now.
Can I audible, sir?
Yes. Share your screen, ऋतुजा.
हॅलो
Screen
सर.
share कर.
Hello.
ऋतुजा, दायजे, share your screen and start.
सर भोयार सरच्या याच्यावरून होस्ट एक्सेप्ट करा.
ऑलरेडी को होस्ट केलंय तुला. तू डायरेक्टली शेअर कर तुझी स्क्रीन. ऋतुजा दायजे.
सर फोन मध्ये पीपीटी शेअर होत नाहीये.
पीपीटी तुमच्या मोबाईल मध्ये तुम्ही ऑन केलेली आहे का?
हॅलो सर, त्या शेअर मध्ये स्क्रीनचं ऑप्शनच नाही येत आहे.
शेअर स्क्रीनची ऑप्शन येते ग्रीन कलर मध्ये तुमच्या मोबाईल मध्ये दिसत आहे सेंटर मध्ये एकदम. झूमचं ऍप मधूनच डाउनलोड केलेलं, म्हणजे त्याच्यातूनच लॉग इन केलंय ना तुम्ही? ठीक आहे. अजून
हेलो सर.
यस.
हेलो
सर
हाँ,
सेम
ऋतुजा
प्रॉब्लम मुझे
दायजेचं
भी मोबाइल में से नहीं
टीचर
सेव हो
बोलत
रहा.
आहे मी सर. हेलो सर, तर भोयर सरांना एकदा पोस्ट करा ना, म्हणजे ती शेअर करू शकते.
ओके, चालेल.
हा.
Sir. Excuse me, sir.
Please wait, Achal Mishra. You talk after this presentation, okay? Okay, sir. Your presentation is visible. Please start.
Can I audible, sir?
You are, but the screen is not in presentation mode.
Sir, make slideshow, sir.
Okay, sir.
Press F5.
Sir, दिसत आहे आता स्क्रीन? हॅलो.
ओके, कंटिन्यू करा. स्लाइड शो करता आली तर बघा.
हां सर. Hello everyone. I am ऋतुजा Madan Daiji from BSc second year, same fourth, Sri Shivaji Science and Art College, Chikhli district, Buldhana. Okay, I am explain the experiment frequency of AC main by sonometer. Aim of the experiment is to determine the frequency of AC main by sonometer. Apparatus of the experiment: sonometer with bridge, hanger, weight magnets, step down transformer, meter scale, etc. We use the formula to calculate the frequency of AC main by the sonometer is n equals to 2 upon 1 upon 2L under root T upon N.
Sir, please take next slide.
Okay.
That slide is not moving, sir. Or close this slideshow and start once again, sir. Sometimes it takes time. क्लोज करून परत सुरू करा सर, मग रन होते ते.
एक वेळेस सर F5 दाबून पहा. F5 E.
ठीक आहे सर, असं केलं तरी चालेल.
Today I explain frequency of AC main by the sonometer. Aim of the experiment is to determine the frequency of AC main by sonometer. Apparatus we use here: sonometer with bridge, hangers, weights, magnets, step-down transformer, meter scale, etc. Formula for to calculate the frequency of AC mains is n equals to 1 upon 2L under root T upon M, whereas n is the frequency of AC mains. T is the tension in the sonometer wire, L is the resonating length, and M is the mass per unit length of the sonometer wire. Now, the diagram of this frequency to calculate. Here we join the transformer. We join the step down transformer. This is the sonometer bridge, and this is the hanger with weights. Now the procedure. First, arrange the sonometer so that the wire is under tension by putting weight in the hanger. Second, the position of the horseshoe magnet in the middle of the wire so that the sonometer wire passes between the two poles of the magnet. Third, make the connection as shown in figure and allow the circuit to pass through the wires. Adjust the position of two sharp beads, retaining the magnet midway between them so that the resonance occurs. Measure the length of the wire between the bridge. Repeat this two times and find mean L. Fifth, note the tension. 6. Alter the tension. Repeat step 1 to 5 for various steps of observation. 7. Take a specimen of wire. Find its mass by weighing and mass per unit length M. Here the observation we calculate the resonating length. Firstly, mass per unit length of the sonometer wire is here 0.035 gram per centimeter. Now observation table, we can taking the reading, mass is 500, then calculate the tensions, later resonating length, then calculate mean, and the frequency is here. Here's the calculation of the frequency. N1 is 46.42, N2 is 48.42, N3 is 47.73, N4 is 47.73, and N5 is 47.60. The mean of the frequency is 47.51. The result of the frequency of AC main band is found to be 47.51 Hz. Precautions. The sonometer wire should have uniform cross section. The sonometer wire and lamp of holding the magnet should be of non-magnetic materials. Third, the magnet should be midway between the bridge, and fourth, the bridge should have sharp edges. Thank you, sir.
Rutuja,
Yes, sir.
please open your video.
Yes, sir.
Show your face.
Video. Sir, I am visible.
Yeah, you are.
Sir, can I perform the experiment?
Okay. Uh, If you are given a wire, how will you find mass per unit length of that wire?
Sir, the formula is given Lm pi r sigma.
Repeat the formula.
Pi r sigma.
What is sigma? What is sigma, beta?
Sorry, sir.
Okay. My next question is, if you
Yes, sir.
increase load if you increase the load, what happens to the loop formed in between the bridges?
When increase the loads, there's are vibration. It's
Okay.
vibration जास्त create होते, sir.
ओके. तो कोणतं व्हायब्रेशन घ्यायचा, किती लेंथ घ्यायची, आपण ते कसे डिसाइड करू?
सर ब्रिजेस ऍड केलेले आहेत सर. जेव्हा आपण लोड ऍडजस्ट केल्यावर ते ब्रिजेस ऍडजस्ट करायचे तर जेव्हा तिथे व्हायब्रेशन क्रिएट झाले ती लेंथ मेजर करायची.
अच्छा. ते लूप फॉर्म होताना दिसते का तुला प्रॅक्टिकल करत असताना?
यस सर.
किती लूप आले होते?
सर प्रॅक्टिकल केल्यानंतर रिझल्ट हा 47 हर्ट्ज पर्यंत.
अच्छा. तशी एसी मेनची फ्रिक्वेन्सी किती आहे ओरिजिनल?
50 हर्ट्ज.
50 हर्ट्ज. ओके. कोणकोणते प्रिकॉशन्स घ्यायचे बेटा प्रॅक्टिकल करत असताना?
Sir, the sonometer wire should of uniform cross section. Magnet should be midway between the two bridges. And the bridge should have sharp edge. Sonometer wire and a clamp of holding the magnet should be non-magnetic material.
ठीक है, वेरी गुड. नेक्स्ट स्पीकर.
So can I try?
अचल मिश्रा रेडी आहे का?
Yes, sir.
ओके, शेअर कर तुझं पीपीटी फास्ट मध्ये. शेअर कर. हॅलो. वैष्णवी वानखेडे आहे का? वैष्णवी महामुने. सुधीर धाबेकर.
येस सर.
सुधीर धाबेकर दिसत आहे.
येस सर.
सुधीर धाबेकर प्रेझेंट करतो तुझं वर.
येस.
रेडी. अचल मिश्रा तुझं शेवटी घेऊ आपण प्रेझेंटेशन. नाउ प्लीज वेट.
सुधीर रेडी.
येस सर. एक मिनिट.
Share your screen and start.
Sir, can you see my PPT? Hello.
सुधीर धाबेकर तुझा आवाज येत नाहीये आणि पीपीटी पण शेअर नाही झाली अजून. थोडा माईक
Can
जवळ
you
घे.
see my... Oh, yes sir. Can you see my PPT, sir? Hello. Hello. Are you there, sir? Hello. Hello. Hello.
Hello, sir. Can I try?
Hello.
Hello, sir. Myself Achal Ananta Kamble.
Achal, share your screen and start. Achal Kamble.
पीपीटी पहिले ओपन करून ठेवा आणि मग शेअर स्क्रीन मध्ये जाऊन लगेच ती विंडो सिलेक्ट करायची. पीपीटी ओपन करून ठेवा पहिले फास्ट.
सर माझी स्क्रीन दिसत नाहीये.
जस्ट कम्प्युटरची एक स्क्रीन दिसत आहे तुमची. पीसीची फोल्डर दिसत आहे.
सर आवाज येत आहे का?
वॉच पण येते. कंटिन्यू करा तुम्ही. शेअर करा लवकरात लवकर.
Achal, what you are doing? Where is your PPT?
पीपीटी ओपन करून ठेवा पहिले फास्ट. जस्ट कम्प्युटरची एक स्क्रीन दिसत आहे तुमची. पीसीची फोल्डर दिसत आहे. वॉच पण येते. कंटिन्यू करा तुम्ही. शेअर करा लवकरात लवकर.
Achal, what you are doing?
Where is your PPT?
You students are not technologically friendly. The presentation should be ready, PPT should be open, and you are in position just like a soldiers.
Okay, next is Sulbha Mungule.
Yes, sir.
Ready का? Okay.
हो.
झालं ना? बरं. शेअर कर तुझी स्क्रीन सुलभा.
Sir, कांबळे start केली. Sir, कांबळेने start केली.
नाही, हे आहे. कोणाची स्क्रीन?
Sir, कांबळे.
सुलभा
सर स्क्रीनचं ऑप्शन दिसत नाही आहे इथं.
तुम्हाला स्क्रीनवर काय दिसते? 4 फोटो दिसतात का? 4-6 फोटो. स्लाइड करा, साइडला स्लाइड करा. स्लाइड केल्यानंतर असं पुश करा स्क्रीनला. छोटासा पुश केल्यानंतर शेअर दिसतो एरो वरचा. त्याच्यात गेल्यानंतर तुमचे डॉक्युमेंट्स आणि तुम्ही जे करत आहे ते बोलत राहा. मला दिसलं पाहिजे तुम्ही काय करताय म्हणून. यू आर जस्ट वेस्टिंग द टाइम ऑफ अदर पर्सन. तुम्ही जे करत आहे ते बोलत राहा. तुम्ही काय करताय तो.
सर इज माय स्क्रीन इज विजिबल.
हा, नो. तुमच्या स्क्रीनवर तुम्हाला काय दिसतं ते सांगा.
सर आता दिसत आहे का?
नाही. तुम्ही शेअर वर गेले का? शेअर SHARE शेअर, त्याला क्लिक करा आणि नंतर फाईल मध्ये जा तुमच्या.
Sir, can I try?
कोण आहे? नाव सांगा.
कोणाचं PPT रेडी आहे सेकंड इयर मधून? अजून ज्यांचं रेडी आहे त्यांनीच फक्त यस म्हणा आणि नाव सांगा.
Sir, Achal Mohan Mishra.
कोण?
Achal Mohan Mishra.
ओके.
तुला ऑलरेडी 2 वेळा आपण ट्राय दिलेला होता. आता रेडी आहे का?
Sir, yes, sir.
ओके, ठीक आहे. ट्राय कर फास्ट. आता तुला केलेलं आहे को होस्ट.
Yes, sir.
बाकीच्या आधी ज्यांनी झूम वापरला असेल त्यांनी पटकन सांगायचं का आम्हाला येते, आम्ही लवकर करतो. ठीक आहे.
Sir, is I am visible?
नाही.
Sir, I am visible?
हो.
Myself Vaishnavi Mahamune, sir. Can I
Wait.
try for presentation, sir?
ओके, जस्ट अ सेकंड. दोघांना करूयात, बघू ज्यांचं झालं ते करू.
येस, शेअर द स्क्रीन.
ट्राय कर वैष्णवी. Yes,
So my
Vaishnavi's
screen is
PPT is visible.
Yeah, it is visible now.
Next slideshow and please start.
Okay, sir. Hello, everyone. Myself Vaishnavi Mahamune. Today I am.
Vaishnavi, your slides are
Hello,
not in
sir.
presentation mode. Presentation mode मध्ये लावा त्याला.
Presentation mode, sir. It's already presentation mode on.
मोबाईल मध्ये आहे का लॅपटॉप आहे?
Laptop.
लॅपटॉप. F5 स्क्रीन आहे ना? F5 की किंवा खाली असते ना ते प्रेझेंटेशनचा. हा, ठीक आहे, ठीक आहे. तेच ना,
त्याच्यावर क्लिक कर.
येस.
Sir, now.
फ्रॉम द बिगिनिंग ऑप्शन वर क्लिक कर.
ठीक केलं.
नाही सर. ती फर्स्ट नंबरची ऑप्शन घे फाईलच्या खालची फ्रॉम द बिगिनिंग. लेफ्ट साइड खाली खाली तिथेच होते ना. परत स्लाइड शो मध्ये जा. ते झूम नका करू तुम्ही. स्लाइड शो मध्ये जा तुम्ही. करू द्यायचं
सर स्लाइड शो इज नॉट
F5 की दाब तुझ्या कीबोर्ड वरची. F5
व्हॉट F5
कीबोर्ड वरती F5 की असते.
ठीक आहे, हे पण चालेल.
ओके कंटिन्यू कर आणि स्लाइड डाऊन एरो ने घेशील.
नंबर 2 वर नंबर 3 वर असे गेले पाहिजे. ठीक आहे.
Okay, sir. Can I start now?
Yeah.
Good afternoon, everyone. Myself, Vaishnavi Muralidhar Mahamune. I am student of BSc second year at MSc Arts, Science and KPT Commerce College, Manora. Today I will discuss about Newton's rings experiment. Firstly, our aim of this experiment is to determine the wavelength of sodium light using Newton's ring. Then apparatus required for these experiments are a nearly monochromatic source of light, which is a source of sodium light, a plano-convex lens, and optically flat glass plates, then a convex lens, and a traveling microscope. Formula required for this experiment is lambda is equals to dn plus p square minus dn square upon 4 pr nanometer. Here dn plus p is the diameter of n plus p dark ring. Then dn is the diameter of nth dark ring, and p is the difference between nth and n plus p dark ring. Then r is the radius of curvature of plano-convex lens. Theory of this experiment is Newton's rings. Here we see this is plano-convex lens. This is plano-convex lens in which upper surface is a plane shape and lower surface is a convex shape, and this is plain glass plate. This is plain glass plate. Lower surface is a convex shape, and this is plain glass plate where a plano-convex lens is placed on the plain glass plate. Here we see the incident ray partially transmitted and partially reflected at curved surface, and then transmitted ray is reflected from glass plate. So these two rays interfere in a reflected line, and interference of these reflected rays observed through microscope. Then next is our diagram. This is the experimental setup of Newton's rings. The experimental arrangement consists of monochromatic source of light as convex lens. This is the plano-convex lens. Then plain glass plate G, then plain glass plate G1, and this is a traveling microscope. From this traveling microscope we can observe Newton's rings. These are the Newton's rings. This type of rings we can see through traveling microscope. The center of Newton's rings is dark, then bright, then this is alternate dark and bright concentric rings we can observe through this traveling microscope. These rings are firstly observed by Sir Isaac Newton. So these these are called Newton's rings. Next is our procedure. This is the experimental setup of Newton's ring experiment. This is plano-convex lens, and this is the plain glass plate. A plano-convex lens of large radius of curvature is placed at with its plain convex surface in contact with the plain glass plate. Then there is an air film is formed between the lower surface of the plano-convex lens and upper surface of the glass plate. The thickness of the air film is 0 at contact point of O, at a point of contact O, and gradually increases outwards. Now consider a monochromatic source of light, and this is monochromatic light as falls on convex lens L from the convex lens here, the light rays becomes parallel and falls on plate G. They incline 45 degree. So from the glass plate G, the light ray will bend with the 90 degree and falls normally on the plano-convex lens, which is kept on plano-convex glass G1. So whenever light rays are reflecting and interfering on the traveling microscope, from this microscope we observe their Newton's rings are formed, which is alternate dark and bright concentric rings. Here we see Newton's rings formation. Newton's rings formation means center of Newton's rings is dark. So there is a question that why center of Newton's ring is dark. At the point of contact, path difference is 0, but one of the interfering ray is reflected. So effective path difference becomes lambda by 2, and there is a minimum intensity condition is created. So the center of ring is dark. So this is the procedure of Newton's ring experiment, and Newton's rings is best application for thin films and interference. Then next is our observation table. This is the observation table of Newton's ring experiment. This is the number of rings which are 5, 10, 15. Instead of that, we can take 1, 2, 3, 4 on so, and there is a reading of a traveling microscope at a left side at a right side. Then a diameter of ring, then a diameter square, then n plus p square minus n square, and then mean value, and then measuring the radius of curvature, we put this all values in formula, which is lambda is equals to dn plus p square minus dn square upon 4 pr nanometer. Then we get the wavelength of monochromatic light. This is the observation table. Result of this experiment. From this experiment, wavelength of sodium light is found to be 5799 angstrom. Precautions for this experiment: the lens and the glass plate should be clean. A lens of large radius of curvature, preferably plano-convex, should be used. Thank you.
Very good, Vaishnavi. So some couple of questions for you.
Okay, sir. Sir, can I start my recorded video?
No,
Okay, sir.
not for the moment. You have to send it to
Okay,
the provided to you. Okay. So the question is, if you replace your sodium light by white light, what will be happen?
Sir, then sodium.
If you replace sodium light by
Replacing sodium light by
white light,
white light.
what will happen?
Then bright. Sir, 1 second. Sir. Sir, changing retro.
Okay, no problem.
Sir, change refractive index.
No problem. You have to search it. Okay.
Refractive index change होता sir.
Okay. Thank you. Next participant.
Okay, Achal Misra.
Yes, sir, I am ready. And sorry for my technical problem.
Okay, please start now.
Welcome to Physics. Sir, I am audible. Sir, I am audible. Hello, sir.
Yes, please start.
I am
Continue.
audible.
Yeah. You are audible.
Experiment. About me, I am Achal Mohan Mishra, Shri RLT College of Science, Akola. I am from BSc second year in P4 batch. My experiment name is to determine the characteristic of PN junction. I am doing my experiment in online mode. Firstly,
we should know that what is P
Audible है क्या?
Before this, I want to clear what is P and N semiconductor. Sir, I am what audible? Sir,
Yes,
Yes.
continue.
P type of semiconductor is obtained when control quantity of trivalent impurity atom such as boron, aluminium are added to pure semiconductor. Trivalent impurity atom has 3 valence electron in its outermost orbit. It means there is a deficiency of 1 electron in order to complete the 4th covalent bond. This deficiency of electron is known as a hole. Every trivalent impurity atom creates one hole, which is ready to accept 1 electron. So, trivalent impurity atoms are known as acceptor impurities. Now, N type of semiconductor. N type of semiconductor is obtained when controlled quantity of pentavalent impurity atoms like arsenic and antimony are added to pure semiconductor. Pentavalent impurity atom has 5 valence electron in its outermost orbit. It means there is a 1 free electron. This free electron is available for electric conduction. Every pentavalent impurity atoms donate 1 free electron. So pentavalent impurity atom are also known as donor impurity atom. Now, how PN junction is formed? When one side of pure semiconductor is doped with trivalent impurity atom and another side of semiconductor is doped with pentavalent impurity atom, then PN junction is formed. It is also known as semiconductor diode. Now, open circuited PN junction, as you show in this figure. In figure, donor ions are represented by positive sign inside a small circle, and free electrons are represented by small holes like. Similarly, acceptor ions is represented by negative ion inside a small circle, and free holes are represented by small holes like. In P type of region, holes are majority charge carrier, while thermally generated electrons are the minority charge carrier. In N type of semiconductor, electrons are majority charge carrier, while thermally generated holes are minority charge carrier. After this, we see formation of depletion region. I requested all you to observe this figure. When PN junction is formed, hole from P region diffuses across the junction toward N region. This diffusion takes place due to their high concentration. Holes from P region diffusing towards N region recombined with equal number of free electron near the junction. So the donor ion near the junction loses their free electron. As a result, there is an excess of positive charge of immobile donor ion. Positive sign inside the circle appear near the junction in N type of semiconductor. At the same time, free electrons from N region diffuses across the junction towards P region. This electron recombined with equal number of holes near the junction. As a result, there is an excess of negative charge of immobile acceptor ion appear near the junction in P type of semiconductor. The negatively and positively charged region produced near the junction in P and N type semiconductor respectively, as shown in this figure. These region do not contain free electrons and holes, but it consists of immobile ion only. This region is called depletion region. Now formation of forward bias PN junction. In this circuit of PN junction, when positive terminal is connected to P type of semiconductor and negative terminal is connected to N type of semiconductor, then PN junction is said to be forward bias PN junction. When we connected positive terminal of battery to P type of region by the Coulomb's law, holes from P region are repelled by the positive terminal of battery and forced to crosses the junction. Similarly, when n type of region is connected to negative terminal of battery, electrons from n type of regions are repelled by negative terminal of battery and forced to crosses the junction. It means that majority charge carrier crosses the junction and constitute a net current due to the motion of holes and electrons. When forward bias is applied, internal potential barrier decreases. That is, the width of depletion region is also decreases. When forward bias voltage Vf increases, correspondingly, forward bias current also increases. As shown in this figure, the right hand side is hypothetical figure and the left hand side figure is drawn by me by the observation. Now we will move toward reverse bias junction. In a circuit of PN junction, when P type of region is connected to negative terminal of battery and N type of region is connected to positive terminal of battery, then PN junction is said to be reverse bias PN junction. At the same time, holes are attracted towards negative terminal of battery and electrons are attracted by positive terminal of battery. So both type of majority charge carriers move away from the junction. That is, at least no current flow through the circuit. At same time, reverse bias condition. Since majority charge carrier are pulled away from junction, the width of depletion region also increases. Through majority charge carrier do not crosses the junction at the time of reverse bias condition. The majority charge carriers crosses the junction, so very small current passes through the junction and it is known as reverse bias character. Sorry, current. The reverse bias character is shown in the figure.
Achal, please come to
Yes,
your result and discussion.
Okay, sir. As we see reverse bias in reverse bias, as we see in reverse bias, less amount of current is flow, and in forward bias, the current is flow. Biasing condition for forward bias: positive terminal should be connected to P type and negative terminal is connected to N type. We take precaution that connection must be tightly, and secondly, applied voltage and corresponding current do not exceed the maximum rating of the given diode. Thank you. Completed.
Okay, Achal, show your face, please. Okay, one question for you.
Yes, sir.
Why PN junction diode does not work in reverse biasing?
Because there is a in reverse bias condition, the depletion region increases due to the opposition of holes and electrons. So there is no flow of current in reverse bias.
Okay. What is mean by doping?
Doping means in intrinsic semiconductor means in pure semiconductor when we added some impure substance like arsenic, antimony, then it is known as doping.
Okay. What is the ratio of doping?
It is depend on temperature.
What is the ratio of impurity added?
Sorry, sir.
Okay. Very good. Thank you.
Sir, I am ready.
Okay.
Hello, sir.
Who is this? Achal Kamble or
Hello,
Sulabha?
sir. I am ready. Mungule.
कोण नाव सांगा.
Sulbha Mungule.
Okay, just a second.
Okay, Achal.
तिचं झालं.
Good afternoon.
Okay, okay. Okay, just wait, Sulabha.
Okay, sir.
Achal Kamble, start.
Okay, sir. Hello, everyone. I am Achalananta Kamble, student of BSc second year. Hello everyone. I am Achalanta Kamble, student of BSc second year at MSP Arts Science and KPT Commerce College, Manora. Today I will discuss about junction fill effect transistor. These are the contents. Aim of this experiment is to determine characteristic of field effect transistor. The first is to plot the drain characteristic of FET and second is to plot the transfer characteristic of FET. The apparatus required for this experiment are field effect transistor, voltmeter, milliammeter, micrometer, DC power supply, rheostat, and connecting wires.
Directly go to the experimental part, Achal.
Okay, sir. Is my screen visible?
Yeah, it is visible.
So what is a field effect transistor? A field effect transistor is a three-terminal semiconductor device in which flow of current is controlled by an electric field setup in a device by applied voltage. In the field effect transistor, current is carried only by majority charge carrier, either holes or electron. So FET is a unipolar device. The three terminal of the JFET are first
Achal,
is a source.
Achal, directly go to
Yes,
the
sir.
experimental part.
Yes, sir.
Experimental part. Go to experimental
Okay,
part.
This is a circuit diagram of JFET. JFET consists three terminal. First is gate, drain, and source. So from source, this terminal. This is a majority charge carrier enter into this terminal, and drain is a terminal. So majority charge carrier leave the semiconducting bar, and gate is a common terminal of both. The voltage across gate and source is a VGS, and voltage across drain and source is a VDS. So next. Procedure first is a drain characteristic. So first is to connect the circuit component and keep gate to source voltage VGS is equal to 0 volt as constant. Now by changing drain to source voltage VDS in step of 1 volt from 0 volt to 10 volts, note the corresponding value of drain current ID. Now keep VGS is equal to minus 2 volt as constant and again change the drain to source voltage VDS in step of 1 volt from 0 to 10 volt. Note the corresponding value of drain current ID. So repeat a similar step for constant value of VGS is equal to minus 4 and minus 6 volt. Second is transfer characteristic. So keep the voltage VDS as constant at 2 volt with the help of rheostat by changing gate to source voltage VGS in step of minus 0.5 volt from 0 until drain current ID becomes 0. Repeat similar step for a constant value of VDS is equal to minus 4 volt and minus 6 volt, and plot the transfer characteristic for tabulated values. These are the observation table of a drain characteristic and transfer characteristic. So first we keep constant VGS is equal to 0 and note with the help of knob we increase voltage across drain and source and measure the drain current. So repeat this step at minus 2 volt and minus 4 volt. And for transfer characteristic, we keep constant voltage across drain and source volt at 2 volt, and we varying voltage across gate and source and measure the drain current. So repeat similar for this minus 4 volt and 6 volt. So result, drain and transfer characteristic for the given field effect transistor is then shown. So this is a graph of drain characteristic. ID is taken on y-axis and VDS is taken on x-axis. So initially the VDS increases, corresponding value of drain current increases linearly up to the certain point after which ID remain constant. And this part of the characteristic where ID increase linearly with the VDS obeys Ohm's law. And after that, further we increase VDS, but ID remain constant. The drain source voltage from where ID become constant is known as pinch off voltage. And the when we further increase VDS at a certain value of VDS, the ID increases, and this increase due to the avalanche multiplication of electron due to the breaking of covalent bond. So, and this is all about drain characteristic. And for transfer characteristic, the value of VGS at which ID is equal to 0 and is called as the gate to source cutoff voltage VGS off. So if we increase ID, VGS is going to minimum. Next is precautions. So first is connection must be tight, and second is applied voltage and the corresponding current should not exceed the maximum rating of the given JFET. Thank you.
Very good, Anchal. So last speaker should be ready. One question for you, Anchal.
Okay, sir.
Show your face, please. Open the camera.
Sir, repeat.
Open the camera.
Okay, sir.
Okay. The next candidate should be ready. One question for you, Anchal.
Okay, sir.
This field effect transistor is bipolar or unipolar device?
Sir, this JFET is a unipolar device.
Why it is unipolar?
Because it consists only one charge carrier.
Okay, okay. Very good.
Either holes or electron.
Okay. So next question is field effect transistor. What is mean by field in this transistor?
Sir, please repeat your question.
What is mean by field? Field in field effect transistor. Why the name is given field?
Sir,
What's the role of field? Okay.
Sir, please repeat.
Okay. The next question. What is the application of FET?
Sir, yeah, FET used in many electronic device, operational amplifier, so, TV, mobile, laptop.
Okay. Very good. Thank you.
Thank you, sir. Thank you.
Next speaker.
Yes, sir. I am Sudhir Davekar, sir.
Sulba, are you ready?
Sir, ready.
Sulba.
Share your PPT.
Share your PPT and start. एक कोणीतरी म्हणत आहे ना तयार आहे म्हणून काय नाव तुझं?
Sir, Sudhir Davekar.
हा. You should ready.
Yes, sir.
After Sulba, you have to present, huh?
Yes.
Okay.
Share your screens.
इतने नहीं हम
सुधीर तुझी स्क्रीन शेअर होत असेल तर ट्राय कर एक मिनिट.
सर इथं म्हणत आहे ओनली द होस्ट कॅन शेअर दिस मीटिंग. हॅलो सर.
ऑलरेडी केलेलं आहे तुझा, चेक कर एकदा.
सॉरी सर, नाही होत आहे.
सर नाही होत आहे ना, फक्त ओनली द होस्ट कॅन शेअर दिस मीटिंग म्हणत आहे सर.
तुला केलेलं आहे ऑलरेडी, तर परत ट्राय कर.
सुलभा
सॉरी सर होत नाही आहे.
तुझा टेक्निकल प्रॉब्लेम असेल, ठीक आहे, होत नसेल तर काही प्रॉब्लेम नाही बेटा.
सर आय एम रेडी सर.
जस्ट वेट सर, थर्ड इयरची त्याला 2 मिनिटं.
हॅलो सर, आय एम रेडी सर.
ओके, स्टार्ट
कर सुधीर.
सर पीपीटी कॅन नॉट बी शेअर म्हणताय.
Can I start?
सुधीर आणि सुलभा पैकी ज्यांचा होत असेल पटकन.
सेकंड इयरचा अजून कोणी आहे का राहिलेला?
Yes, sir.
नाव सांगा.
Radhika Dasturi.
राधिका दस्तुरे. राधिका दस्तुरे. शेअर कर तुझी स्क्रीन. ऍड करून
सर ते धनंजय भोरच्या याच्यावर स्क्रीन शेअर केल्या सर.
ओके भोयर सर.
हॅलो, धनंजय भोरच्या याच्यावर
म्हणजे बोर.
ओके स्टार्ट करा सर. Yes, please continue, sir. This is right.
Yes, sir. I am audible, sir.
Yes, you are.
Hello, everyone. I am Radhika Milind Dasture, student of BSc second year from Sri Shivaji Science and Arts College, Chikli, District Buldhana. Today, I am going to explain the experiment which have titles Verify Stephen's Law.
Go to slide number 2.
Now,
slide change करना. Second slide वर जाना.
the aim of experiment is to verify Stephen's law of radiation by using an incandescent lamp. We have to use apparatus is experimental board, patch cords and patch cord, multimeter and etc.
Radhika,
Yes, sir.
your slides are not moving. You are on the first slide till time. पहिली स्लाइड दिसत आहे मला, दुसरी वर जाय, तिसरी वर जाय.
आता दिसतंय, sir. दिसतंय, sir.
हा आता दिसतंय. ठीक आहे.
Okay. Now, the aim of experiment is to verify Stephen's law of radiation by using an incandescent lamp. Apparatus, experimental board, patch cord, multimeter, etc. Now, the formula for temperature of filament is T is equal to TR in bracket RT upon R bracket complete raised to the power 0.833. Now the formula for filament resistance is RR is equal to RD into TR upon 800 raised to the power 1.2, where T is the temperature of tungsten filament, TR is the room temperature, RT is the resistance of bulb filament at particular temperature, RR is the resistance of bulb filament at room temperature, ID is the resistance at Draper point. where sigma is the Stephan constant, A is the surface area of filament, and E is the emissivity. This is the diagram of a given experiment. This gives the DC power supply. This is the tungsten. This is the bulb. Now the procedure of the given experiment is: first, starting from low current, increase it gradually by potentiometer till the filament of the bulb just grow. This is called the draper point. Note down V and I at this draper point. From this, calculate ID of the resistance of bulb filament at draper point. Third one is note down the room temperature by thermometer and calculate the filament by using the given equation. Fourth one is increase the voltage in step and note down voltage VT and IT and calculate the resistance IT and power P at particular temperature. Next, to plot a graph by taking log of 10t on x-axis and log of 10p on y-axis. We get a straight line. Here, this determines the slope of line. Sixth is also determine the intercept on y-axis. This gives the log sigma. Taking an anti-log of this given value, the value of Stephan constant sigma gives. This is the room temperature is 19 degree. To it convert into Kelvin, it is 290 Kelvin. Then it is the bulb resistance at draper point. ID is equal to VD upon ID. This is the calculations for filament resistance RR. This is the observation table which is performed by me. This is the readings of voltage. This is the readings of current with respect to voltage. This is the ID. ID is the resistance of bulb filament at particular temperature. This is the values. This is the values of power P, and this is these values taking of log of P. This is the temperature of tungsten filament, corresponding values, and we are taking this log of T. Then we plotted a graph between log of T and log of P. On y-axis, we take log of P, and on x-axis, we take log of T. Then it gives a straight line, and this is the slope of given line. It is 2.314 into 10 raised to power minus 6. This is the calculations for temperature of filament, tungsten filament. Then the result is the value of Stephan constant found to be 2.134 into 10 raised to power 6 watt meter inverse Kelvin inverse raised to the power 4. This is the experimental value 2.134 into 10 raised to power minus 6 meter inverse square. This is the standard value, and this is the percentage error. Percentage error can be calculated from standard value minus experimental value upon experimental value into 100. This is the precautions. Because during the measurement of RD, the voltage and current of DC power supply should be as minimum as possible. Second is the resistance at particular temperature RD to be found in each setting of voltage and current of DC power supply. The value of RR and RT should be same. Thank you, sir.
Very good. Sudhir.
Yes, sir.
One question for you, Radhika.
Yes, sir.
Why the percentage error is very large? And what precautions you can take to minimize that error? Have you got my question?
No, sir.
Okay, next question.
Yes.
Why you used tungsten material?
Tungsten material because it has high temperature.
Very good, very good, very good. Okay, thank you.
Thank you, sir.
सुधीर,
हाँ सर, 1 मिनट.
1 मिनट नहीं है आपके पास, जल्दी करो.
हाँ.
सर श्रद्धा मुंगले.
Here you are PT.
सेकंड इयरचा अजून कोण आहे रेडी?
सुलभा मंगुले.
Okay, सुलभा.
सर यांचा प्रॉब्लेम प्रॉब्लेम असा आहे
PPT
का?
नॉट.
हॅलो.
हा सर, माझी PPT होतच नाही आहे सर.
Okay, कोण तू?
सुधीर दाभेकर.
होत नाही, त्यांच्यासाठी आपण काय करू शकत नाही ना.
सर मी काय म्हटलं,
कोण
माझ्या
तुम्ही?
स्टुडंट मी सर वांड्रे सर बोलतो, आर्ट्स कॉमर्स सायन्स कॉलेज मारेगाव.
बोला सर.
माझ्या स्टुडंटची पीपीटी शो नाही होत आहे सर, तर मी पीपीटी शो करतो, ते एक्सप्लेन करेल मला. चालेल का सर?
सर हे सर ओके सर, यू कॅन शेअर अँड ही कॅन एक्सप्लेन.
सर मला पण पोस्ट करा.
केला
मीटिंग.
रुपेश वांड.
रुपेश सर, यू आर को होस्ट नाव.
ओके सर. नाही सर, नाही केलंय सर, कोर्स नाही केलाय.
यू आर को होस्ट नाव.
हो ना
सर, ये रुपेश वंधारे को करना है. रुपेश वंधारे सर को आपको
प्रेजेंटेशन
येस सर.
झाला सॉल्व.
नाही सर, सर शेअर करणार आहे.
कोणतं सर?
सर.
ठीक आहे. सर त्यांना होस्ट करा. वंधारे सर नाही आहे ना.
होऊ शकत नाही. यांना होस्ट केलं.
सुधीर सर, तुम्हाला काय प्रॉब्लेम आहे?
सर मला पोस्ट नाही केलं. ऍक्च्युली सुधीर दाभेकरला होस्ट केलाय, त्याच्यामुळे प्रॉब्लेम होऊन राहिला.
अच्छा, तुम्ही कोणतं सुधीर?
सुधीर दाभेकरला होस्ट केलाय सर. त्याच्याकडे पूर्ण मॅनेजमेंट त्याच्याकडे गेल्या पूर्ण. त्याला लेफ्ट व्हायला लागेल, कारण तुमच्या हातामध्ये काहीच नाही सर. सुधीर दाभेकर जागे चुकीनं तुमच्या बाय मिस्टेक होस्ट
करतो सर. ठीक आहे.
त्याला हा सर झालं. तुम्ही नाही सर होल्ड सर. हा सर ठीक आहे चला. ओके.
Rupesh Vandhare, sir, please share your screen.
Screen share.
Hello,
Hello.
am I audible, sir?
Yes, you are.
Sir, I am from MSP Capital College, Manora, from BSc third year. Can I present, sir?
Okay. Navi.
If it is not.
Hello. Shall I start my presentation, sir?
You belong to BSc final,
I am
na?
from BSc third year.
No. Presently, we are taking BSc part 2 only. Yeah?
Okay, sir.
We are taking a break of 5 minutes. Okay. Wait for 5 minutes. All participants are requested to take a break of 5 minutes.
Dear participant, please wait for 5 minutes. Take a break or be ready with your presentation. After ending of the second year student, third year students will start soon. Just, I think one candidate is remaining from the second year. So third year students, be ready. ओके. हॅलो, कोण रेडी आहे सध्या? Whose presentation is ready? हॅलो, कोणाचं प्रेझेंटेशन रेडी आहे? ओके.
हॅलो सर.
कोमल काशानी, आर यू रेडी?
Yes sir.
Okay, I will make
सर शेअर करू.
yes, please share your screen. बसून जा सर.
सर स्क्रीन शेयर का ऑप्शन नहीं आ रहा है.
Using a mobile phone or laptop?
सर मोबाइल फोन.
त्याच्यामध्ये एक शेअरची ऑप्शन येते.
नहीं सर नहीं आ रही है ना. कैमरा वेब URL डॉक्यूमेंट वगैरह ही आ रहा है. शेयर स्क्रीन शेयर नहीं आ रहा है.
शेअर नावाची ऑप्शन आली असेल.
नहीं सर.
ओके, अजून नेक्स्ट पार्टिसिपंट कोण आहे ज्यांचं पीपीटी रेडी आहे?
सर पूजा आवारी.
ठीक आहे. Okay, please share your screen, Pooja.
Yes.
सर कोमल काशी सर नसेल तर त्याच्यानंतर आहे ऑनलाईन मध्ये ऐश्वर्या पाठक.
ओके सर, ज्यांचं पीपीटी रेडी आहे त्यांना आपण घेतोय पहिले.
बरं ठीक आहे ना. जे रेडी आहे त्यांना चालू करा. वैष्णवी सुरकुसे, साक्षी राऊत, पूजा आवारी एवढे 5 विद्यार्थी आहेत ऑनलाईन. त्यानंतर राधिका गंधारे आणि श्रद्धा शेगोकर.
तुझ्या तुझं स्क्रीन शेअर कर.
सर इथे व्हिडिओ शेअर नाही होत आहे का?
पॉवर पॉइंट नाहीये का तुमचं?
सर प्री रेकॉर्डेड एक व्हिडिओ पाठवायचा होता ना मला, तो पण दाखवायचा होता. मी पॉवर पॉइंट मध्ये रीडिंग्स रेकॉर्ड नाही केले आहे.
ठीक आहे ना, जेवढं पॉवर पॉइंट असेल बेसिक तेवढं सांगून द्या त्याच्यामध्येच.
अच्छा, आणि व्हिडिओ प्ले नाही होणार तो?
नाही, ठीक आहे ना, त्याचं इव्हॅल्युएशन नंतर करण्यात येईल. तुम्ही फक्त प्रेझेंट करा तुमचं बेसिक. आणि
कारण मी जो एक्सपेरिमेंटचं जे सगळे रीडिंग्स आणि डेमॉन्स्ट्रेशन आहे ते सगळं व्हिडिओ आहे. पॉवर पॉइंट मध्ये मी फक्त प्रॅक्टिकलची एक थिअरी प्रिपेअर केली आहे.
थोडं शॉर्ट मध्ये सांगा त्याच्यामध्येच. ओके
ठीक आहे. एक मिनिट सर. सर मग माझ्या आधी कोणी पार्टिसिपेट करत असेल तर मी 5 मिनिटात थोडं हे
ओके
करते.
ठीक आहे चालेल. Who is next?
Sir,
Yes,
can I start, sir?
Vaishnavi. Please tell your name and start your PPT. Vaishnavi, share your screen.
सर एक बार करके देखती हूँ, मैं ड्राइव से, मैंने ड्राइव में सेव किए हैं.
Please wait, Komal. Okay, Komal Kashani, you should also try for once.
सर आता सेकंड वेळेस देऊ शकणार नाही का?
Please wait, sir.
ओके.
Sir, is my screen is visible?
Yes, please start.
I am Komal Kashani from Sri Shivaji Science College, Amravati, BSc final year, and my experiment name is to determine specific charge by helical coil method. Now we will firstly see content. Firstly we will see history. Then we will see aim, apparatus, theory, procedure. Then we will see calculation and result. Then precautions. Now we will see some theory. J.J. Thomson in 1856-1940, a British physicist, was born in Chethamon Hill, a suburb of Manchester, on 18 December 1856. He was awarded the Nobel Prize in Physics in 1906 for his work on the discovery of electrons. He directed the Cavendish Laboratory at Cambridge for 35 years, and 7 of his research assistants subsequently won Nobel Prizes. Now we will see aim to determine the value of E by M for an electron by helical coil method. Now the apparatus required for this experiment is cathode ray tube, CRT power supply, DC power supply, solenoid, rheostat, DC voltmeter, and connecting wires. Now we will see some theory about this. Electrons are emitted from the cathode, accelerated by the anode, are deflected by electric field to give a line on the fluorescent screen. The current carrying solenoid which enclose the cathode ray tube provides the necessary magnetic field. Focusing it, alternating potential is applied to the plates, then the electrons shall experience a transverse alternating force. Under influence of this potential, we shall get a line on the strength on the applied potential. Now, if the longitudinal field because of solenoid is electron in circular path is balanced by the centripetal forces supplied by the magnetic field. Now, this is a popular method to find E by M. In this method to find E by M, the cathode ray tube is placed inside the solenoid if B is the magnetic field to make the spot them, and the formula used to calculate the E by M is E by M equals to 5 into 10 to the power 13 into L square into VA divided by N square I square into L square, where L equals to distance to screen from deflecting plates, N is the total number of turns of solenoid, L is the length of solenoid, VA is the accelerating voltage, and I is the solenoid current. Okay, now we will see the procedure. Firstly, we will place the solenoid such that its axis lies in the east-west direction. Now, the power unit should be kept as far away as possible to avoid the stray magnetic field. And we mount the cathode ray tube inside the solenoid at the center. We will see here.
And now we will switch on the power supply and set the knob of this multimeter to the alternating voltage, and increase the accelerating voltage from this knob, and then we get the desired value of voltage from in the multimeter. Now we will set this knob to the X plate, and we will find the value for Ix. So firstly, we will increase the current. We will increase the current till the line is reduced to the small point. This current is in ampere, in Ix. Okay. Now we will set this knob to the Y, because we have to find the value of Iy, and we will repeat this all steps. Means we will increase the current till the line is reduced to the small point, and we will get the desired value of Iy. So we will see here the observation table, and in this we have the value of accelerating voltage, Ix and Iy. So from which we can find the accelerating voltage. Here we can see that the accelerating voltage we will find from this step. We will set the knob in the accelerating voltage and increase the accelerating voltage till then we will get the desired value, and we increase the value of accelerating voltage many times. Okay, so we will get the accelerating voltage from those steps, and now we have to find the value of Ix. So the value of Ix we will find from this step, that firstly we have to set the knob in X plate, and then we will increase the value of the current till the line is reduced to the small point. When the line is reduced to the small point, then it gives the value of current. Then it is Ix value, because we set the knob to the X plate. Now similarly we find the value for Iy, and this is the observation table. We increases the accelerating voltage, and we will calculate three values here. Firstly, we will get accelerating voltage 537. We will get 537 accelerating voltage. Then here we got Ix 2.14, and here we get Iy 1.55. Now we will calculate the all values from this formula. E by m equals to 5 into 10 to the power 13 into L square into VA divided by n square I square into L square. Okay, now we will see the result. This is the experiment value, that is 1.23 into 10 to the power 11, and the standard value of E by m is 1.6 into 10 to the power 11, and there is a percentage error 0.37 because of the instruments. There is error given, and there is some precautions. First, the solenoid should be along east-west direction, and the second one is the value of solenoid current and accelerating voltage should be read carefully. Third one is the cathode ray tube should be placed symmetrically within the solenoid. Thank you.
There is any other method for calculating the specific charge?
Yes, magnetron method and Thomson bar magnet.
Okay. What is the separate value of E and M?
E and M. Electron is 1 point.
Yes, yes.
Huh?
Yes, continue.
1.36 into 10 to the power 11.
Value of E. What is E? What is E here?
Electron.
E is electron or charge on electron?
Yes, charge on E is electron.
Okay. And what is M here?
M is the mass of that particle.
What is the mass of that electron? What is the value of mass of electron?
Mass of electron. Sorry, sir.
Okay.
Okay, who is next participant? Who is ready? Tell me your name.
Shall I present?
Pooja,
Sir, please make me host.
नाव सांगा तुमचं.
Vaishnavi Surduse from BSc third year.
ओके, शेअर करा तुमचं पीपीटी.
Yes, sir.
Yes, your PPT is visible. Please start.
Okay, sir. Hello everyone. I am Vaishnavi Surduse from BSc third year at MSP College, Manora. Today, I have performed the experiment already in a video recording. The aim of my experiment is to determine the temperature, difference, resistivity, and energy band gap of semiconductor using 4-probe method. The apparatus required for this experiment is 4-probe apparatus, including oven, thermometer, dope sample with mica sheets, and a sample holder, etc. Theory required for this experiment is band gap energy. Generally, it is defined as a gap between conduction band and valence band. For the germanium, energy gap is 0.7 electron volt, and second one is resistivity. Generally, it is known as electrical resistivity or volume resistivity, which is intrinsic property of material that can oppose the how strongly given material to oppose the flow of electric current. The formula for require this experiment is rho 0 equals to V divided by I into 2 pi s. Here rho 0 is the resistivity, which is in ohm meter. V is the potential difference between the inner probe volts. I is the current through the outer pair of probes in ampere, and S is the spacing between the two probes, that is in meter. For a thin sample, the modified formula is rho equals to rho 0 divided by G7 into W divided by S. The correction factor G7 W divided by S equals to 2 into S divided by W into log of 2. In this formula, we give the true resistivity of the semiconducting material. This is the diagram for this 4-probe method. This is a volume high impedance volumeter. This is a probe. Distance between two specimens whose resistivity is to be measured by using this line. This is a 0.2 centimeter approximately. Here is the constant current applied for this circuit. This is the diagram for energy band gap of semiconductor. Here is the voltmeter. Here current measure, thermometer. Include in this. This is a copper vessel. In this includes a thermometer and oil, and this is a wooden box. Now we will see the procedure for this experiment. Take all the apparatus which we have mentioned already in the apparatus. Connect the one with 4-probe setup and connect the red and black wire to the 4-probe setup and current knob and voltage knob. Now turn on the 4-probe setup by varying a current to adjust the current to keep the current constant according to your choice. Note down your constant current and proceed ahead. Now move the knob for a voltage measurement. Now take a first reading at room temperature, and then after that start your oven. As the temperature increases, note down the corresponding voltage. After that, taking a heating port voltage, now switch off the oven and take the voltage for the cooling port. Then you will see your heating and cooling voltage is approximately same. Now we will have already formulas and to determine the resistivity and energy band gap, and plot a graph log rho versus 1000 divided by t and find the slope and determine the graph. It should be 0.7 or less than that. This is my observation table, which we have already given in a video, which is link provided by you. This is the temperature at 35 degrees Celsius. Also, it is a temperature in Kelvin, which is converted into degrees Celsius to Kelvin. Electric current, I have taken electric current at 1 milliampere. This is a potential drop, which is a mean of cooling voltage and heating voltage. This is the resistivity rho in ohm. This is calculated by log rho and t raised to t into 10 raised to power minus 3 for the graph. This is my calculation for the correction factor. I have calculated. Okay, sir. Result for this experiment, my result is equals to 0.7104 in electron volts. This is my graph, which is obtained by the my observation table and calculation. Result of this experiment is the given crystal found to be germanium, which is the energy band gap value of energy band gap is 0.7, while the standard value of band gap energy for the germanium is 0.7 electron volt. Precaution for this experiment deals with the sample very carefully because of costly about it is 2000 to 3000 rupees fixed on the 4 probe. Thank you very much, sir.
Hello. Okay. Which material here we use as a semiconductor in your experiment?
Germanium, sir.
Okay. What is the band gap if you use the silicon semiconductor? So what will you get our result? Band gap?
0.3 electron volts, sir.
What is the band gap of silicon semiconductor?
0.3 electron volts.
Now, when the temperature is increasing, okay, inside your container, when the temperature is increasing, then what actually happen inside the semiconductor?
Energy band, as the temperature increases, energy increases. But sometimes
what will happen for electron and hole pair? Okay, sir.
Sorry, sir.
Okay, sir. Please next.
Okay. Who is next participant? Please tell me your name first.
Sir, Pooja Avari.
Make you post, share your PPT. Start.
Sir, hello, sir.
Share your
Hello?
PPT, Pooja. PPT share नाही का होत तुमची?
Sir, 1 minute, please.
Sir, can I start my presentation, sir? Myself, Sakshi Raut, sir.
ठीक आहे, साक्षी राऊत तुझं पीपीटी शेअर करेल का?
Sir, make me host. Sir.
साक्षी राऊत तुला को होस्ट केलेलं आहे, शेअर करा तुमचं वर. यस, स्टार्ट झालं. लोड होतंय, जस्ट अ सेकंड. ओके,
Sir, is this my screen is visible, sir?
ओपन करा त्या पॉवर पॉइंटला आणि स्लाइड शो करा. डबल क्लिक करा त्याच्यावर.
Sir, is this visible, sir?
पॉवर पॉइंट ओपन केलं का तू? डबल क्लिक कर ना त्याच्यावर, साक्षी राऊतवर. नाही तर परत शेअर स्क्रीन मध्ये जा आणि जे पॉवर पॉइंट ओपन आहे त्या विंडोला शेअर कर.
Okay, sir.
ती ओपनच राहू दे. शेअर स्क्रीन मध्ये जा परत. यस,
Sir, now visible, sir?
स्लाइड शो कर त्याला जमत असेल तर, नाही तर मग कंटिन्यू कर.
Okay, sir. Can I start now, sir?
Yes, you can start.
Sir, myself Sakshi Raut, and my experiment name is to determine the BH curve and the hysteresis loss in the transformer core. For this experiment, we have to use the apparatus that is like a experimental unit to study BH curve and the core. Second is the CRO. Third is the trace paper, and fourth connecting wires and the graph paper. For this experiment, the formula is given as the formula for hysteresis loss per unit volume per cycle is given as the current into voltage into area of BH loop upon the F pi area of the rectangle joule per cycle, where I is the current in primary ampere and V is the voltage across primary winding corresponding to the current I, and the frequency is already given as the 50 Hertz. Now procedure for this experiment is the circuit assemble on the board and all necessary connection are built in. Connect the point A and B to Expt plate and switch on the supply to the unit. Adjust X and Y amplifier of CRO to get platter with the screen and obtain BH curve. Obtain proper shape of BH curve. For that, adjust X and Y amplifier very carefully. Note voltage V and current I. Obtain proper shape and put the tracing paper on screen with axis coinciding with H axis and B axis and trace the curve on the paper. Retrace the BH curve on graph paper. Find the area of loop and the area of rectangle. Select some new value of voltage and current. Repeat the same procedure. Theory for this experiment is the hysteresis loop shows the relation between the magnetic flux density and the magnetic field strength. The loop is generated by measuring the magnetic flux coming out from the ferromagnetic substance while changing the external magnetic field. Looking at the graph. Graph is not put input in this PPT. Roughly, I can show the diagram of hysteresis loop. The magnetic flux density we increase when magnetic field strength H is increased from 0. With increasing the magnetic field is an increase in the value of magnetism and finally reaches point A. It's called saturation point where B is constant. Reduce the value H back to 0. Now the value magnetism M of specimen is not 0 but has some finite value. Point B represented by OB and it called as the retentive point. If the value H is now increased in opposite direction, the value of magnetization M of specimen decrease and becomes 0. Point C when the value of H is OC and this point called as coercive point.
Now, if the value of H a further increase in opposite direction till the again saturation point stage of the magnetization is reaches point D, and this point D is known as coercive point. Now decrease the value of H to 0. The value of magnetization B of specimen has finite value point E by OE is called retentive point. On increasing the value of H in positive direction, the part EFA trace, the figure shows a magnetization curve on or an associated hysteresis loop A, B, C, D, E, F, A. This is my observation table and the calculation. I have measured the current for the calculation and the potential difference means voltage and the area of loop and the area of rectangle. And all the value are put in the formula and given the result is I have measured it for only a first reading, that is current is 20, potential is voltage is 220 and the area of loop 152.5 and the area of rectangle is 100. And finally I have got a result for H loss. Hysteresis loss of the specimen transformer unit volume per cycle is found to be H loss, and my H loss is 42.7388 joule per cycle. And we can see the graph of this BH loop. Thank you, sir.
From the hysteresis loop, what we can find?
सर तुमचा आवाज नाही येत आहे सर.
From the hysteresis graph, what we can find? Why we draw the hysteresis loop?
For the
okay, for which material here we use for plot the hysteresis loop?
Ferromagnetic substance, sir.
Can we get a same graph for diamagnetic or paramagnetic material?
No, sir, because it doesn't show the BH loop, sir.
Okay. Next.
Okay, who is next participant? Ready
Sir,
आहे?
please. Sir, पूजा आवारी.
शेअर होत नाहीये वर, काय प्रॉब्लेम काय? ठीक आहे, एकदा लास्ट ट्राय करा आता.
हा, येस, एक मिनिट.
त्याच्यानंतर अजून कोण आहे त्यांनी पण रेडी राहा, नंतर ऐन वेळेवर मग परत प्रॉब्लेम येतो. नेक्स्ट कोण आहे, लवकर नाव सांगा त्यांचं.
ऐश्वर्या पाठक.
ओके, ट्राय टू शेअर युअर पीपीटी.
सर मी थेअरीवर बनवली आहे पीपीटी.
जे असेल ते शेअर करा. ऐश्वर्या, जे असेल ते शेअर करा लवकर.
ओके सर.
5 मिनिटांमध्ये प्रेझेंट करा तुमचं वर्क. ओके, अजून कोण रिमेनिंग आहे?
Yes, sir. I'm Radhika Gandhare.
पीपीटी रेडी ठेव तुझं लगेच.
Yes, sir.
Co-host करतोय. Without wasting a time, please share your PPT fast and try to finish in 5 minutes.
Okay, sir. Sir, there is no option to share screen.
मी ऍप्लिकेशन इन्स्टॉल केलेलं आहे का झूमचं
Yes, sir.
मोबाईल मध्ये?
Yes, sir. Yes, sir.
स्क्रीन वरती टच केल्याच्या नंतर खाली 3 ऑप्शन्स येतात.
हो सर, मी त्यातच आहे आणि आधी करून पण बघितलं आहे सर मी, पण इथे शेअर स्क्रीनचं ऑप्शन नाही येते.
झूम ऍप तुमचं परत एकदा हे करून घ्या, अपडेट करून घ्या त्याला.
सर मी जस्ट आताच ट्राय करून बघितलं, याच्या आधी पण एका मीटिंग तेव्हा झालं आहे. सर प्लीज आय कॅन जॉईन अगेन.
शेअरची ऑप्शनच येत नाहीये का तुझ्यामध्ये?
नो सर.
को-होस्ट केलंय मी ऑलरेडी.
सर मला शेअरचे ऑप्शन येत आहे, बट जेव्हा मी डॉक्युमेंट फॉर्म मध्ये पीपीटी खुलत आहे ते ओपन नाही होत आहे.
काम कर, पीपीटी ऑलरेडी ओपन करून ठेव.
हा,
मग शेअर
ते आहे
स्क्रीन मध्ये
open.
जा आणि ती विंडो सिलेक्ट कर.
सर माझं पण शेअर नाही होत आहे. शेअर ऑप्शन येत आहे पण करता नाही येत आहे डॉक्युमेंट मधून.
ऑलरेडी तुमचं पीपीटी ओपन ठेवायचं एका आणि त्याला मिनिमाइज करायचं. परत झूम मध्ये जायचं, शेअर करायचं आणि ती जी ओपन आहे विंडो त्याला शेअर म्हणायचं. मग ती स्क्रीन बरोबर शेअर होते फक्त. किंवा सेकंड ऑप्शन असं आहे की त्याला परत शेअर मध्ये जायचं, लोकेशन द्यायचं त्या फाईलचं पर्टिक्युलर जिथे तुम्ही ठेवलेलं आहे फोल्डर मध्ये.
सर पण शेअर वर प्रेस केल्यावर ते सगळे ऑप्शन्स येत आहे, जसं गुगल ड्राईव्ह, बॉक्स, फोटो, डॉक्युमेंट. बट ती जी पीपीटी आहे
ऑप्शन इज नॉट विजिबल देयर. सेम प्रॉब्लेम.
शेअरची बटन सुरू केल्यावर मी आता माझी विंडो खुलली आहे आणि पीपीटी ओपन केली आहे, पण ती तुम्हाला दिसत आहे का आता?
नाही, तुझी स्क्रीन शेअरच नाही झालेली आहे.
हा, तर मी शेअरवर प्रेस केल्यावर तिथं फक्त ते ऑप्शन्स येत आहे. जसं तुम्ही म्हणत आहे की मिनिमाइज करून करा, ते तसं होत नाहीये.
सर प्लीज मेक मी को-होस्ट.
ऑलरेडी आहे, तुम्ही ट्राय करा. परत ट्राय करा एकदा. अजून कोण राहिलेला असेल तर त्यांनी पण शेअर करा. ज्यांचं शेअर झाली स्क्रीन आपण त्यांचं घेऊया.
नो सर, इथे ना शेअर स्क्रीन हे ऑप्शनच नाहीये.
तुम्ही युट्यूब वर आता शिकून घ्या हाऊ टू शेअर द स्क्रीन.
नाही सर, ते जमते ना, ते केलंय मी आता जस्ट आधी 5 मिनिटं आधी करून बघितलं माझ्या फ्रेंडच्या याच्यावर, पण इथे ऑप्शन नाही येते.
तर सेम प्रॉब्लेम इथे शेअर केल्यावर मिनिमाइज करून शेअर नाही होत आहे. तुम्ही ट्राय करून बघा.
हॅलो सर, मला वाटते 4च जण आहे. हा, झालं.
ठीक आहे, अजून कोणी रिमेनिंग आहे का? हे 4 टेक्निकल प्रॉब्लेम सोडून अजून कोणी आहे का?
येस सर, आय एम श्रद्धा.
ओके, तू पण शेअर कर ना, तुला ऑलरेडी मी को-होस्ट केलंय.
हो सर, पण माझ्या याच्यामध्ये पण स्क्रीन शेअर ऑप्शन नाहीये.
नाही सर, सेम प्रॉब्लेम आहे सगळ्यांकडे, स्क्रीन शेअर ऑप्शनच येत नाहीये.
मे बी सेटिंग मधून काहीतरी फॉल्ट आहे.
बाकीचं सर्वांचं प्रेझेंट झालेलं आहे.
हो
सेकंड इयर
सर, आम्ही आधी पण करून
सर आमच्या
बघितलं.
याच्यात दिसत नाहीये ना, ते ऑप्शनच नाहीये सर.
एकदा लिव्ह करून परत जॉईन करा.
ठीक आहे
सर, ते अलाउ पार्टिसिपंट टू शेअर स्क्रीन हे ऑप्शन ऑन असेल का ते बघून घ्या सर, प्लीज एकदा चेक कर.
बाकीच्यांचं होतंय, तुमचंच होत नाही, तर मग अलाउ करायची काय गरज आहे? एकदा तुम्ही एक्झिट करा, परत जॉईन करा.
ओके सर.
कारण सकाळपासून प्रोग्राम चालू आहे, कोणालाच अडचण आलेली नाही.
Sir, my screen is visible.
No. रुपेश वंधारे सर, तुमचं काय प्रॉब्लेम आहे सर? रुपेश वंधारे सर, तुम्ही मगाशी कॉन्टॅक्ट केला होता. ओके, ज्यांचं पीपीटी होत नाहीये रन, आपण त्यांचा व्हिडिओ प्ले करू आणि त्याचं इव्हॅल्युएशन करून टाकूयात. ठीक आहे
सर, आम्ही आधीच व्हिडिओ प्रोव्हाइड केला आहे लिंकवर. तो व्हिडिओ प्ले होऊ शकते का सर? हॅलो सर.
ओके, ज्यांचं पीपीटी नाही झालेलं आहे त्यांचं व्हिडिओ बघून आम्ही इव्हॅल्युएशन करू. ठीक आहे
सर. हॅलो सर. हॅलो सर, आम्ही आधीच एक व्हिडिओ पाठवला आहे, तो तुम्ही शेअर करू शकता का सर?
नाही, त्याचं इव्हॅल्युएशन करतील आता बाकीचे सर लोक. ठीक आहे, त्याच्यावरून तुमचं
सर
काय असतील मार्क्स वगैरे देऊयात. टेक्निकल इश्यू असल्यामुळे आता तो सर्वांची इथं प्ले करता येणार नाही एकदम.
सर, पण आम्ही खूप मेहनत केली आहे, तर आमचं प्रेझेंटेशन झालं नाही तर.
बघा, तुम्हाला आता मी को होस्ट म्हणून केलेलं आहे, तुमचं शेअर व्हायलाच पाहिजे होतं वर्क. तुम्ही आता तुमच्या एंडला
हो
काहीतरी
सर,
प्रॉब्लेम
पण आमच्या याच्यात शेअर स्क्रीन हे ऑप्शनच दिसत नाहीये. बाकी सगळे ऑप्शन आहे. मायक्रोसॉफ्ट वन ड्राईव्ह आहे, गुगल ड्राईव्ह आहे, बॉक्स, फोटोज,
पीसी
डॉक्युमेंट.
मधून लॉग इन केलं की मोबाईल मधून केलेलं आहे?
सर, मोबाईल मधून.
मोबाईल मध्येच मोस्टली हा प्रॉब्लेम येतोय. ज्यांनी पीसी यूज केलं ना,
नाही सर,
सर्वांचं
पण
run झालेलं.
याच्या आधी मी जी मीटिंग झाली ना सेकंड इयरची, तेव्हा बघितलं. ऍक्च्युली
एक
मी
काम कर, एकदा
तिच्या
लेफ्ट
लिंकवर
कर,
जॉईन झाली
एकदा
होती तेव्हा
लेफ्ट
माझी
करून मीटिंग लेफ्ट कर आणि परत रिजॉईन कर एकदा.
हॅलो सर.
यस
सर, मी रिजॉईन केलेलं आहे. मला एक वेळा को होस्ट करा.
ठीक आहे.
आय एम श्रद्धा.